Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in 8051 microcontroller. We're going to see addressing modes of 8051, and this is going to be a very important question in this particular unit and very important concept to understand the instruction, how we have to give the instruction, how we have to program. This is going to be very basic for programming in microcontroller, right? So what is addressing modes? Before seeing this different addressing modes, we'll just see what is addressing mode, right? We would have come across a lot of instructions like move R1 comma R2, right? Add R1 comma R2, something like that. You have given some instructions. Even in your lab, you would have executed all these instructions, correct? Right. So addressing modes tells you how should we give data, source or destination, right, or the address to 8051, right? How is that we have to feed data or the address to the instruction? That is called as addressing mode. And you have different types of addressing modes in 8051, which is immediate addressing, direct addressing, register addressing, register indirect, implied, relative, indexed, and absolute addressing, right? So we'll see one by one. First, we will start with immediate addressing, and before that, whatever I said about addressing mode, you can see that the way in which data source and destination addresses are specified in the instruction. How a data, that is source data or a destination data or an address, is represented in the instruction, right? That is called as addressing mode, right? And before seeing this addressing modes one by one, I'll explain what is what in this particular slide so that you can remember or you can relate whenever you study the different addressing mode, right? From the name itself, you can understand what is that addressing mode is all about, right? The first one is immediate addressing mode. What is immediate addressing mode? Very simple. Whenever we need to immediately add any data, right, that is, we can directly give data to the instruction, right? In the instruction, we can directly give data, say for example 06, like this, right? So you have this hash symbol and followed by you'll give some value. In 8051, whatever which is followed by this hash, it's a data, right? So by using immediate addressing, what we can do is we can directly give the data. That is why it is called as immediate addressing. Immediately we can give the data, right? And the next one is register. What is register? Instead of giving the address directly, that instead of giving data directly, we can use register, right? R0, R1, R2, like that. If you're using registers, R0, R1, R2, R3, like that, any registers, right? That is called as register addressing mode, right? And what is direct addressing? You can see here from the name itself, you can understand. Direct addressing is, you can see here in immediate, we have given data directly. But in direct addressing, we will directly give the address, right? The instruction will have the address directly. We can directly access the address. That is why it is called as direct addressing mode. And what is indirect addressing? Indirect addressing, this is just opposite of direct addressing. Right? What is indirect addressing? Instead of giving this address location directly, what it will do is it will give the location where the address will be. Say for example, at R1, at R2, right? What is that at represents this indirect addressing? That is, we have to get the data by going through R2, right? We have to use the data which is in the R1. That is, we have to access the memory location which is in the R1. Right? So the address will not be directly given, where it will ask you to go somewhere and get the address. That is called as indirect addressing, right? And what is index addressing? Index addressing, once again, you can see you will use index pointer. That is, you will use DPTR or program counter. That is, in indirect addressing, what we will do is the address will be given indirectly, right? That is, say for example, if it is at R1, right? We have to go to R1 to get the address which is 0F. That is indirect addressing. But index addressing, what we have to do is we have to calculate the address. That is, the microcontroller has to calculate the address. How it will calculate? Based upon the index register and the accumulator value, that is accumulator value plus the DPTR. What is the value at DPTR or program pointer, like that. By adding this two, it will get the address information, right? Like that, it will calculate the effective address. That calculation is called as effective address. So in indexed addressing, we will use index pointers to calculate the address. We have to calculate it, right? What is relative addressing? You can see there is relative, absolute, and as well as long. Relative addressing, it is used to that is similar to this index addressing. We will also calculate the address here, but this address, that is the address is calculated for the jump instruction, jump or call instruction, right? That is called as relative addressing, right? Whenever we need to jump, right, this will be used for jump instruction. For that, we have to know from which address to which address we have to jump, right? So that address will be calculated by using relative addressing, right? So you'll have an offset value. Based upon the offset value, it will calculate and it will jump. Say for example, if the current memory location, right, if it is just for an example, right, if it is 0001, right, and it has the offset value of 4, right, then what it will do is it will go to the second value 0, so that is it, the program counter will be incremented to this next instruction, and then it will add plus 4 to it, so it will jump to the 00006 instruction, right? So based upon this, how to jump, based upon the offset value, right, that is called as relative addressing. It will calculate the address where we have to jump, that is relative addressing. And you have something called absolute and as well as long addressing, right? Absolute addressing, this is also used in call instruction, call or jump instruction, right? And this is also used for call or jump instruction. What is the difference? Absolute is 2-byte address and long is 3-byte address, right? Absolute, when you ever say absolute, it can use program memory, that is the code memory within 2 kilobyte, right, which is the internal memory, right? Within 2 kilobyte, if you want to call a program or if you want to jump, we can use absolute program. If you want to access the complete external memory, then we have to go for long addressing, right? So by this, you would have understand what are the different addressing modes, right? Now we will see one by one, right? We are just going to see the examples of it, right? So what is immediate addressing? You can see the immediate addressing, the simplest way to get the data, right? And whatever I said is given in this particular information, right? You can see this example, move A, hash 12. That is, what does it mean? This hash 12, that is immediate addressing. Whenever you use this symbol, that is immediate addressing. We have to move this 12 data to the accumulator, right? And similarly, you can see here, we have to move this data to DPTR. DPTR is a 16-bit register, so it is a 16-bit data, right? So that is, whenever we need to feed data directly to the instruction, we can go for immediate addressing, right? Immediate addressing is very, very fast, right? And you have one disadvantage, that is, whenever it is going to compile, right, the compiler will not be very flexible with this immediate addressing because everything is fixed in immediate addressing, right? And we will see about register addressing. As I said, very simple. Whenever it is register addressing, you will have registers in the instruction itself. That is register A, DPTR, R0, or so on like that, right? You can see here multiple A, B, which is multiply AB. That is, it will multiply this content and this content. Similarly, you can see add A, R7. That is the content in the R7, right? It is moved to this, that is added with the accumulator and save the data in the accumulator. And increment DPTR. DPTR is a register, right? So whenever you use this DPTR, R0, R1, accumulator register, right, directly, right, then that is called as register addressing, right? And what is direct addressing? As I said, direct addressing, like immediate addressing, instead of data, we can directly give the address value. You can see here 55H. That is the content in the 55H plus the accumulator has to be added and save it in the accumulator, right? And you can see here the content of the accumulator, it will be moved to this port 1, port address, right? So whenever the memory location is given directly, then that is called as direct addressing, right? Direct addressing is quite faster and it is it has greatest advantage when compared to immediate. That is because immediate, while compiling, it is not variable, it is fixed, so the compiler has some difficulty. But here, right, the address, we have to check the address, and then the data is not given directly, so it is variable, right? So you can see here it is much flexible than immediate addressing, right? So what is direct addressing? Direct addressing, we can directly give the address location in the instruction itself. That is called as direct addressing. And the opposite of this, indirect addressing. What is indirect addressing, right? And before going to this indirect addressing, you have to know one particular point in direct addressing. In last video, we have seen memory organization of 8051. We have already seen how the general purpose registers will be accessed, right? What addressing modes will be given, right? The upper 128-bit RAM, right? Upper 128-bit RAM, we say that special function register, right? Those special function register will be accessed by using direct addressing. But the upper 128-bit, right, which is not comes under the apart from the special function register, right, that will be accessed only by indirect addressing, not by direct addressing. Only special function register will be accessed by using direct addressing, but apart from that, other locations will be accessed through indirect addressing, right? And now we will see what is indirect addressing. So indirect addressing, as I said, you will use registers R0, R1, DPTR, everything, but here the address location will be given indirectly. You can see here at R0, at DPTR, at DPTR. What does it mean? The address. What we have to go to this R0, right, to know the address location, right? So what is the information here, right? It will move A comma R0, right? So now what it will do, the content which is found in this particular location, first we have to go to R0, right, to find out the address location, right? So that address location, right, indicated by R0, right, that content which is in that particular address location will be moved to the accumulator. You can see here, load the accumulator with the value from the internal RAM which is found on the address indicated by R0, right? So R0, if you go to R0, what it will do, it will have an address, right? That address location, whatever value present, that has to be moved to the accumulator, right? Similarly, you can see here, move external address X. Whenever we use X, that refers to the external address. Move X A comma A DPTR. That is, it's not about the content of DPTR moved to the A. What we have to do? We have to go to the content, right, that is specified by the DPTR. The address location is given by DPTR. We have to go to that address location. The content in that address location, that has to be moved to the accumulator, right? And similarly, the same thing here. The accumulator, we have to move the accumulator value to DPTR, not to DPTR, the address location pointed by DPTR. Whatever address location given by DPTR, we have to move the content of accumulator to DPTR, right? So what is register indirect addressing? We have to, the address will be given indirectly, right? That is called as register indirect addressing, right? And indexed addressing. I already explained what is indexed addressing. Indexed addressing, you will have base pointer, right? That is base register, right? That is, it can be DPTR or program counter. We also use accumulator to calculate the address, right? We call it as an effective address, right? Whenever you use jump instruction or move C instruction, like that, right? So which means you can see here, this is an example, move CA, right? Whenever we need to access external memory, we use this move C, right? So move CA, this is the information to calculate the effective address. Now you have to calculate the effective address. What you have to do? You have to find out the memory location, the address, right? The address is found by adding the accumulator and the DPTR value, right? So you will find out the address. Address itself you will be finding out only after adding the accumulator value and DPTR value, right? And after finding that address, right, we have to move the content which is found in that address to the A. You can see here the instruction moves a byte of data in this particular location to A, right, to the accumulator. The address in the code memory is found by adding accumulator and data pointer, right? So you don't want to get confused with indirect addressing and indexed addressing. Indirect addressing also right, you can find out the address directly. That is, it will give the location where you can find the address directly. All you have to do is you have to go to R0 or R1 to find out the address location. But index addressing, the controller has to find out the address itself, right? That is, it can be finding out by adding the accumulator and DPTR here, right? And then it goes to that address, and whatever value which is present in that address, that is moved to the accumulator. Hope you are clear with this index addressing, right? And next we will see about relative addressing, right? So relative addressing, as I said, it is used for jump instruction, right? And you will have an offset value. Once again, it will also calculate the effective address, that is when we have to jump, right? And this is all about theory. That is, it is minus 128 bit to 127. It is an 8 sign bit value, right? And one thing you have to understand, whenever we apply a relative addressing, right, the program counter will be incremented to 1, and then it will go to the jump instruction, right? Now to understand this relative addressing, right, you can see this example so that you can really understand, right? So you can see this is the memory allocation, right? This is the registers, right? The memory locations, right? You can see here 0, it starts with 100, 101, 2, 3, 4, 5, 6, 7, 8, 9, like that, right? And you'll have a data saved in all these instructions, correct? Now, understand one particular thing here, right? Now, what happens here? Now, here it is jump instruction. You will get a S jump, right? S jump. Now, how it will calculate the jump instruction? Now, you can see here, it is 0100. It is 0100, right? This is the offset value. You can see here. Here is the location where the jump instruction will be executed, right? This 05 is nothing but the offset value, right? So this offset value is the one which we have to add, right? But where we have to add, you can see here, right? Whenever we get this offset value, right, the program counter, whenever we get the jump instruction, right, the program counter will be incremented to 1, right, from here, right? That is 0102. This is the offset value. So this memory location, it will be incremented to 1. From here, from 0102, we got to add the offset value, which is 5, right? So what you will get? 7010. So from here, it will jump to 0107. Right? So this is called relative addressing, right? So we have to find out the offset address. How is that I can able to find out the offset address? I need to find out by using this particular offset value, right? And you have to calculate from this address, not from here, right? And similarly, you can also do this way. That is, jump can be either forward or as well as backward. And you can see this example where the memory location starts from 38, 39, 3A, 3B, 3C, like this, right? You can see here, as I said, the jump can be either forward or backward, right? You can see the offset value is F6 here, right? What is F6, right? What is F6? F6 can be represented like -10, right? This is the hexadecimal value, right? And the corresponding value F6 is -10, right? So now what happens here, right? We know what is the offset value, that is -10. So from this particular jump instruction, right, first what it will do is it will increment to this particular program counter, right, 2042, and from here it will decrease -10. That is, will go to the address location of -10 from here, right? So it is -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. So it will jump to this 2038, right? So the offset value is F6. So the address location will jump to 2038, right? Now you understand what is relative addressing, right? So this is very important for jump instruction, right? And whenever you say jump instruction, we also use absolute addressing and as well as long addressing, right? What is absolute addressing, right? So absolute addressing, right? First you have to understand what is jump and what is call instruction, right? So here absolute addressing is used for call and as well as jump instruction. What is call and what is jump? Call is nothing but whenever whenever you are executing a main program, right, and whenever there is, you have to execute a subroutine, a subprogram, a subroutine program, we go for call instruction, right? So what it will do is, while executing the main program, like if there is a call instruction, it will go to some other location, right? It will execute that particular program, right? And then it will return from from subroutine, it will return to the main program. This is call instruction. And what is jump instruction? Right? It will execute one particular program, right? And whenever there is jump, it will jump to the next memory location, right? It will jump either forward or backward. That is about jump. You got to understand what is the difference between jump and as well as call, right? And absolute addressing here, it uses 11-byte address, right? So it is a 2-byte instruction, right? And it is used for short call and jump. That is absolute call and absolute jump. What is absolute call and what absolute jump? Whenever you need to call a program or jump to a memory location within 2 kilobyte internal RAM, right? Within 2 kilobyte of program memory, right? Then we can use this absolute addressing. Within 2 kilobyte, right? We can go for absolute addressing, right? So we can call any subroutine or jump to any location within this 2 kilobyte, right? This internal memory, right? So, and that we can be able to access. For absolute addressing, we will use 11-bit address, out of which the 11 least significant bit address of the opcode, the upper 5 bits are the current 5 bits of the program counter, right? So we'll use 11-bit address, right? And what is long addressing? Long addressing, the same thing like absolute call and absolute jump, but here it is called long call and long jump. That is, it is not only internal memory, we can go for the complete 64 kilobyte programmable memory, right? That is external memory. The complete external memory can be accessed, right? And this is 3-byte instruction, right? You can able to access 64 kilobit code space program memory, right? Whereas the absolute addressing can be accessing only the internal program memory, right? And you can see here we can give the 16-bit addressing, right? It is complete 16-bit address, that is the long jump, right? So it can go to this particular address, right? That is about long addressing. You got to understand the difference between absolute and as well as long addressing, right? And the last one is implied addressing. Implied addressing is a single byte instruction, right? So absolute is 2-byte instruction, where long is 3-byte instruction, implied is 1-byte instruction, right? So it will be directly given, that is, these are the instruction given for any specific work, right? Say for example, you can see this particular instruction, oral, right? Rotate left, right? That is, it will the accumulator value will be rotating left, right? Swap A, the upper nibble and the lower nibble of the accumulator has to be swapped, right? Like this, if it is a direct instruction, that is called as implied addressing, right? So today what we have seen is, we have seen very important concept in 8051. We have seen the addressing modes of 8051, right? I believe this video will be very useful for you. Thank you, students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.